Today we're going to take our first step to clearing up one of my oldest pet peeves. Fn is not freaking equal to Fg. How could they be equal? They're in opposite directions. You know what? They don't even have to be in opposite directions though, do they? So hang on. Fn is not equal to Fg. Let's do a couple of examples to make sure that this is clear to you. Let's say we had a 50 kilo box just sitting there at rest. There would be gravity on the box, of course, and gravity would be equal to 50 times 9.8, which is 490 newtons. The box is at rest. It's sitting there. Its acceleration is equal to 0. No one is pushing on it or anything. It's not in an elevator. It's not on a ramp. It's just sitting there at rest. So there's got to be a force up. And that force up, of course, has to be the normal force. And if I write my y direction equation, I'm going to call x to the right because I usually do, then my y equation would say Fn minus Fg. It's just sitting there at rest, nothing else is happening. That's going to equal 0. Therefore, the normal force will equal 490 newtons. Okay. So Fn can be equal to Fg. But that doesn't mean it has to be. And that's what kids get wrong so often. Let's do another example. How about somebody comes along and they lift up on the box with a force of 90 newtons. So it's the same box. It's got an Fg still of 490. Now somebody comes along and pushes up on the box. Let's call that F. Let's call that F up. Let's call that F up. It's equal to 90 newtons. Now, is the box still on the surface? It is. So there is an Fn. I'm going to put a question mark there because I don't know how big it is yet. What's my y equation? Same coordinate system as before. My y equation is that Fn, which is positive, plus F up, which is also positive, minus Fg has to be equal to 0 because it's still at rest. It's being pulled upwards, but not by enough. What did I say the upwards force was? Only 90 newtons, I think I said. And that's not enough to lift it up. So Fn plus Fu minus Fg is equal to 0. Therefore, the normal force in this case is going to be 490 newtons minus 90 newtons, which is only 400 newtons. Which is, of course, less than the weight of the box. Fn is not equal to gravity. Fn is as big as it needs to be to make sure the box doesn't sink through the floor. And if nothing else is going on, that'll be gravity. But if someone else is messing with the box, then the normal force will have to change to compensate. Let's have the same situation. Let's say we've got that same box. Gravity is pushing down on it with a force of Fg. This dude, F up, is still pushing up on it with 90, but now some other dude comes along and pushes down to the right with a force of Fa. And let's say the applied force was, 300 newtons. This other person comes along and pushes with 300 newtons to the right. Let's write it over here. Fa equals 300 newtons. Is there a normal force? This thing is still on the surface, so there is a normal force, but I don't know how big it is. X and y. X is still to the right, y is still up. Fa is not in my x or y direction, so I've got to break him into components. I've got to break him into Fx, which I'm going to ignore for this question, and I'm going to break him into Fy, which is down. Okay? I'm going to, though, draw Fy over here. I'm going to draw it over here so I don't forget about it when I'm doing my y equation. Okay? Now, this angle is 30 degrees. So the applied force is 300 newtons, 30 degrees below the horizontal, which means that Fy is the sine of 30 times 300, which I happen to know is 150 newtons. So what's my y equation going to say now? Fn is still up. F up is up. Fg is down, so minus Fg and minus Fy. The box is not sinking into the ground. It's not flying off the ground. Its vertical acceleration is still 0. So what do we end up with? We end up with Fn is going to be equal to Fg plus Fy minus F up. And that's going to be 490 plus 150 minus 90. That's 550 newtons up. The normal force is up in all three of these examples. But can you see how the normal force is sure as heck not equal to gravity? In the first case, there was. So I can put my Caruana marks. I can put on my Caruana marks after I do the math and I see that they're equal. In this case, no Caruana marks because these two added up equal gravity. None of these two forces are the same. Over here, I've got all kinds of forces going on. Fy, Fg, F up, Fn, and sure, Fn is... it's complicated. So you've got to make sure you actually do the math and don't just ruin your whole question by assuming Fn equals Fg. Wrap it up, Morin.